This meeting is being recorded.
In this video, we're going to explore sample exercise 5 from chapter 15 on chemical equilibrium. And below here, we're given this reaction. We're actually given two steps within the reaction, the elementary steps, and we're given below those elementary steps the overall reaction. So let's point out here, we have our overall reaction is down here. We have step 1 and step 2, and each of these steps has their own Kc values. We have Kc1 and Kc2 here, we can call them. So in this question, we're asked to determine our Kc for the overall reaction. So we're asked to find our Kc overall. So what we can do is take each of these steps, and you should have read in your textbook ways that you could manipulate these steps and also change Kc values to essentially add these two equations together to get this overall reaction. So as these two reactions stand now, we wouldn't get the this overall reaction. So let's take a look at step 1 here, and we have HF, our reversible arrow here for our equilibrium reaction, and then our products are H plus and F negative. So let's take a look in our reaction down here. We see 2HF. So I know that I'm going to need to multiply this first reaction by 2. So I'm going to do that. So we get 2HF, and then our double-headed arrow will yield 2H plus and 2F negative. All right, so when we multiply a reaction by 2, we're going to have to raise that to an exponent. So we're going to end up squaring this value over here for our Kc1. All right, so let's make a note of that. So our Kc1, the final version of that will have to be squared in our final equation. Let's take a look at our second step here. And I notice that this reactant is actually a product, and my product here that I'll box in is a reactant over here. So that means that I'm going to have to flip this second reaction, and then I would take the inverse of this Kc value. So that would end up being 1 over 3.8 times 10 to the negative 6. And that's our final version of Kc2 that we'll use in our calculation. But in the meantime, let's invert this equation here. We already have 2H plus, so we're going to end up with C2O4 2 negative plus 2H plus will then yield our H2C2O4. So now let's try to add these equations up, see if we can get our overall reaction. First, you'll notice on this side of the reaction, on the reactant side, we have 2H plus. On the product side here, we can cancel these out, just like we did with spectator ions, in Chem 1 when we looked at net ionic reactions. So overall then, we're going to add these up. We get 2HF plus C2O4 2 negative, reversible arrows, gives us 2F negative plus our H2C2O4. So that matches this equation here. So that means that all we have to do to find our K overall is to multiply together 6.8 times 10 to the negative 4th squared times Kc2, 1 over 3.8 times 10 to the negative 6. So if you do these step by step, you'll see the square of this is about 4.6 times 10 to the negative 7, and then we still have to multiply by 1 over 3.8 to the negative 6. That's about 263,158. So now our Kc overall will be the product of these two, which you get about 0.1196, or when we round down to 2 digits, because that's all we were given above for significant figures, our Kc overall here for this reaction would be 0.12.